Hi, welcome back to DevOps Easy Learning, AWS Cloud session. In this session, we are going to be deploying an application load balancer. In the previous session, I showed you guys how we can actually set up a network load balancer and deploy. But now, showing you how to route requests to different EC2 instances based on URL paths or domain name, just like in a real-world microservice or multi-app architecture. As you can see from your screen here, we have three servers, which we already pre-configured and set up, and each one has an application running in it, web application running in it. So let me confirm that again. So this is application one, and let's go to application two. It's application two, and application three has another web server running in it as well. So as you can see, these are the three servers we have. And what we're going to do is we're going to set up a route-based, path-based routing here with application load balancer, which is a feature with a application load balancer that we will not find with a network load balancer. And when we set it up, we're going to set it so that when every time we punch the URL, we're going to point it to a particular server so that that way it only shows us what we need to see in that particular server. So to give you guys an example what each server looks like internally, let me SSM into one of these servers. You can see, and in here, if I cd into the var www html and I say ls, you can see I have the ls is showing me right here. So what we are going to do is that we will be creating another folder here, and I'm going to be creating the folder, name it app folder one, app folder two, app folder three in each of those folders. So app folder one will be created here. And in fact, let me just go ahead and create that. So say pwd, this is where I want to be. Supposed to run with sudo app one. All right, I'll show you the index.html. This is actually our landing page for our server that I just showed you guys. So this is what we have in there. I'm just going to take this and I'm going to put it in because we are trying to do a path-based routing, and path-based routing requires us creating a folder that we can copy this into. So if I say ls, it shows me that I have, let me do it this way. It shows me that I have a directory and a file. So what is going to happen is that I'm going to copy this file, this index.html file, I'm going to dump it right in here. Root to do that. All right. So if I say ls, you can see I have the index.html file. If I cd into the app one and I say ls, you can see I have that in there as well. And we're going to do this for each of those servers, server two, server three as well. It's fine. Let's do that in server two. Yeah, there should be for HTML, and I name this one app two. Okay. Why do I keep forgetting to run my sudo before running this command? All right, so I'm going to copy var HTML index, and I'm going to put it in here. var HTML app two. I'm supposed to put a sudo in front of that, or else it will run permission denied. All right, so if I say ls-la var html app. All right, so this is what I'm trying to see. Okay, let's go and do the same for our app 3. Right. All right, you're going to do the same. Create a folder, and then I'm going to copy everything I have in there. All right, so I say ls-la la bar html app 3. I will see this is what I want right here. Cool. Now, so this is what our architecture looks like at the that we are trying to achieve. For now, we have an EC2 instance with a directory called app1 with an index.html file in here. Same thing with EC2 server 2 and EC2 server 3. So now we're going to create a load balancer with a target group and create set up a path-based routing that will tell our load balancer every time we call this URL with app 1, please take us to server 1. When we call the URL with app 2, please take us to server 2. And app 3, when we call app 3. To instance and start with our target group. So scroll all the way down, going to click target group, and we're going to click create target group and instances. So my advice would be at the very first step, when you're creating this, we'll give it a name, ALB target group. We're going to create a default first, and then we will come back and create our paths in our listener role. So the L check, you can leave it as root, click next, and we're going to select all 3 instances, include a spending below, create target group. Now, while the target group is loading, cooking, remember from our network load balancer series, we stated that you need to have all 3 uh, EC2 instances present and healthy here for it to work. While this one is cooking and getting ready, you can see from here, it should tell us that initial is 3, but eventually it's going to say initial is 3, and then it's going to point us all 3 EC2 instances here. So while this is getting ready, let's open our load balancer and create an application load balancer. So I'm going to click create, and this time, the last time we used this network, but this time we will be using the application load balancer. Just going to click create, and I'm going to give it name application LB demo. And it's going to be internet facing as well. We're going to use the IPv4 uh, uh, address type, and network mapping. We'll be using all our EC2 instances and our default VPC. So I need to confirm that. Yes, I think so. They are all in my default VPC. So we're going to leave it at the default VPC, and as pick at least two availability zone. But in my case, I'm just going to pick all availability zone, so it don't really matter. And security group as well, very important. Make sure your security group has the protocol in place. When we checked the last time in our network load balancer demo, we saw that all 3 its servers were using a default server. And if I click this, you can see it's the default security group, and the other one, default security group. And finally, the last one, the default security group. And just to confirm that we have the protocol in there, we have our HTTP protocol setup. Now, something very important to note here is that if you are setting your load balancer with SSL, it means that you need to have the HTTPS protocol in that security group. This will allow you to have the 443 protocol, which is for secured web browser. But for this demo, we are only going to look at this. In subsequent demo, we will look on how to set up an ACM, we are Amazon Certificate Manager, with our network, our application load balancer for a secured SSL termination traffic. So let's go back to and see where we are at present with our target groups. And still pending. While that is pending, let's talk a little bit about application load balancers. Let's know how we need to know. Now, with application load balancers, you can see here that it says that it automatically distributes your incoming traffic across multiple targets, such as an EC2 instance, containers, IP address in one or more availability zone. It helps to monitor the health of your registered targets and route traffic only to the healthy targets. And that is why we are saying right here that we can't even move forward until it shows us that we have all three LT EC2 instances permit up right here. Let me see where we are. And we still, but at least the good thing is that it's showing that there are three unused, and we'll still continue. So let's talk some more about that. So Elastic Load Balancing supports the following load balancer: application load balancer, network load balancer, but we are looking more on the application load balancer in this demo. So it serves as a single point of contact for your client, which means everyone who is trying to hit your EC2 instance must first hit the URL of your load balancer in order to actually reach your application. The load balancer distributes incoming traffic across multiple targets, such as an EC2, in a multi-availability zone. This increases the availability of your application. So, an application load balancer can also function like a network load balancer that, you know, directs traffic evenly across EC2 instances. Now, a very important concept in network load balancing and application load balancing is a listener checks. So the listener is a rule, it's like a rule that checks for the connection request from clients using a protocol and the port that you configure. So the rule defines for the listener what type of traffic is coming in and through what port that they're using. And if it's coming through a particular port, what EC2 instance you should direct it to. Every target group routes requests to one or more registered targets, such as an EC2 instance using the protocol. Now, this is how it looks like. The load balancer, you know, it listens to the target groups and see where the targets, the rules are set and where to send the traffic to. So remember, the target groups are like just a grouping of EC2 instances. Now, some of the benefit of migrating from a classic to the present application load balancer is that the application load balancer supports path conditions, host conditions, and HTTP header conditions. These are actually really good if you guys are trying to separate the flow of traffic to certain application. Okay, so taking a look at this documentation, guys, come over here, get to understand what this they're saying, so it will help you understand how you can set up your listener rules in there. We're going to do it, so I'm going to try my best to explain it to you guys as best as I can, so you guys get it. All right, let's go back and see where we are with our provisioning. So, all right, now that we've selected our security group. For the listeners, remember we with the network load balancer, the protocol gives us the TCP option, but here with an application load balancer, we only have these two options, this protocol. We're going to use our 80, and then we're going to select the target group that we just created, and we scroll all the way down and create load balancer. So our load balancer is being created. It's provisioning as we speak. Once this is ready, we can use this DNS and try to see if we can reach our target group. Let's see where we are on this one now. Still, okay, it has moved from unused to initial. That's good. Progress is being made. Very soon, it's going to become 3LD and we can test. So while we're waiting, I'm going to pause the video and we come back when everything is fully provisioned. Still here. All right. Let's in order not to waste too much time, I'm gonna go ahead and create the target groups that I want to create because remember we have three instances. Since we're doing a path-based routing, I want to separate those three instances into three target group. So right now you can see we've initially set this up like just the same way as a network load balancer. But for an application load balancer, to make your life easy, you want to create more target groups, and each target group should be for a different application. So first and foremost, we will create one for the target group one. Name this one target server one group, HTTP, VPC HTTP, protocol, everything the same. Click next, and I'm going to select this one right here, which is server one, include a spending below, create. I'm going to do the same for the other two as well. Right. As you can see, we now have uh, four target groups with each target group created for a particular application. And also you can see right here, it says that they are non-associated with any load balancer. Let's go ahead and associate each of these target group with the application load balancer we just created. So let's see what we have with the target groups at now. Okay. We have four target groups, target group one, two, three, and non-associated. But let's see if this target group is ready. It is ready. Now we have our three EC2 instance registered. Now I think our load balancer is also ready as well. Yes, it is active and ready. So all right, now we see we have our four target groups here. We don't really need this ALB target group here because we are doing path-based routing. But this one is going to function like a network load balancer before an application load balancer. That if you get what I'm trying to say. But in our case, we actually do not need this one. Focus on the path-based routing with these three target group for now. Now, to do that, we are going to go into our load balancer, select our load balancer. We're going to go to listeners and rules. And here we're going to select this listener because we're using the HTTP 80 listener rule. So we select that and we're going to go to manage rules and edit rules. And from here, I'm going to select this and click to add a new rule because we don't need this default one anymore. I'm going to add a new rule. And in this new rule, I'm going to say for every traffic, we want to direct traffic to server one. And you're going to select that target group, click next. At least one condition is needed. Oh, oh yeah, I'm supposed to add condition. My bad. So right here at the top, we're going to click add condition. And since we're doing a path-based routing, you're going to select that. And for the path, the first server, remember when we created the first server, we created in a forward app one server. So I'm going to say forward app one, and I'm going to put an asterisk here, and I'm going to click confirm, select this box. and it's going to forward that to this target group and click next. And we're going to give this priority 1 and click next. And that is all. Click create. We're going to do the same, add another rule. Let me name this one, say name this rule server app 1 to be easier for us to understand each of those one when we see it in the listener. So go back to my listeners, and we have server 1 rule. I'm going to add a new rule, and same thing, condition, path-based routing, forward app 2 forward asterisk. So this says, uh, please use any URL, any path after app as our landing page. So next, select this, and this time we're going to point it to target group 2, and next, and we'll make this one priority 2 and give it a name. Next, I think we can't do that right now. Rules tag, great. And I'll name this one server app 2 rule. And finally, the last one, add rule, condition, add the condition, path base 3, Eric's, confirm, select that, select server 3, next, priority 3, next, great. And I will give this one a rule name. Right. So we've just created 3 rules. This for server 1. So any traffic that will point with a URL app 1 should please take that traffic to server 1. Any traffic that is point with the URL path app 2, please send to target group 2. And any URL with path app 3, please send to target group 3. And this is how you set your path-based routing in an application load balancer. But before we actually test, I want to make sure that each of these target group has one healthy at the one LT EC2 instance in them. So I'm going to go back to target groups and click refresh. And as you can see right now, it's actually before when it was showing no load balancer associated with it. Now it's showing that we have application load balancer associated with it. So let's check the each of this one. Okay, this one is good. We have one here and this one too. It's healthy, beautiful. You can see it right here. And the last but not the least, it's right here. All right, so we see that our target groups are good. Our load balancer, it's ready. Let's test this out. So select that, go all the way down, collect the DNS, and watch this, guys. This is where you have to, make the path-based routing work for you. So when you drop the DNS, remember we have our servers running in app 1, app 2, app 3 directories. So I'm going to click that, and this will show us server 1. Now, if I go back up here and I change the path-based URL to app 2, watch, it's going to change. And same thing, if I switch to part 3, app 3, it will change as well. Now, this will continue this way. It will always point to the server that we have created it for. Don't get confused about this. I know if you don't do this, oftentimes you might actually, mess it up. So you can attach an SSL, as you can see, it's showing right here, says not secured. You can actually attach SSL certificate from an AWS certificate manager to your HTTPS listener. So when you add it to the listener, the HTTP listener right here, you attach your ACM to read to this. It can actually help to secure your traffic with TLS. In our next series, we are actually going to practice that. We're going to see how to generate an ACM certificate and how to secure our application load balancer uh, traffic with the TLS. Always monitor your ALB access logs in S3. So it's good you set up an S3 monitoring log for your ALB. Use CloudWatch metrics, for alerts, very important. And use weighted target groups for blue-green deployment. Now, for those of you who are uh, going deep into DevOps, that is something we will show you in one of the subsequent DevOps classes, how you can actually use weighted target groups for blue-green deployment. Always try as much as possible to avoid using dynamic URLs for path-based rules. Use host-based where possible if you don't want to stick with a path-based routing. Now, that is it for setting up your EC2 based web app architecture with application load balancer. You now know how to route traffic with smart rules and serve multiple apps behind a single DNS. In the next episode, like I said, we will see how we can secure it with a ACM for a TLS certification secured browser. And after that, we will now take a look at Elastic File System as a scalable file system that can be mounted on multiple instances. And with that, we've come to the end of today's demo. And I want to thank you all for spending your time with me today. And I'll see you guys in the next demo. Thank you.